Good afternoon, all. Today we have a new Samvaad Talk series with the theme Models of Computational Thinking, and we have Dr. Deshmukh to give a talk on data-driven decisioning. Dr. Deshmukh is CEO and co-founder of TildeHat. He has a PhD in machine learning from University of Maryland. For almost a decade, he worked with IBM Research and Xerox Research on various state-of-the-art machine learning projects. Dr. Om has 50 plus international publications, several of Best Paper Awards, and 50 plus patents filed and granted. In 2019, his data science team at Yardley was recognized as one of the top 10 data science teams to work in India. And in 2017, he was recognized as one of the top 10 data scientists in India. His team in 2008 had won the Government of India's National Award for the Best Accessible Technology. He is well known for machine learning and data sciences with several collaborations across IISc and IITs. He is also a faculty at International School of Engineering. So I welcome Dr. Om to present his talk today.
So thank you so much for coming for my talk, and wish you all a very happy 2020. And I'm also honored and privileged to be the first speaker for the year. So thank you, Professor Jaya and Professor Srinivasan, for giving me this opportunity. What I thought I'll do is talk a little bit about not any particular machine learning technique or go deep into any deep learning algorithm or any such thing that we've used in my previous organization, which is Yardley, or what we are doing now, but talk a little bit about what is the kind of quote-unquote culture that you need when you're building a machine learning solution. Yeah, and stop me if there are any questions, or stop me if there is, if you think this is not relevant, and so on. Yeah. So, and thank you, Ms. Rani, for giving a wonderful introduction. What I thought I'll do is also sort of lay out how the different pieces of my career connect with what I'm trying to do now. So on one extreme is theoretical machine learning or theoretical PhD in any particular topic, right? And so I did that in 2006. I finished my PhD in what today gets called as data science, but when I was doing my PhD, it was just PhD in speech recognition, and it happened to be, using HMMs and hidden Markov models, basically. So that's what I had done. Went quite deep in one topic, which was in this case HMMs, hidden Markov models for speech recognition, and then its applications to speech enhancement, LVCSR, large vocabulary speech recognition, and so on. Then, so I took all of that deep, what gets today called as deep data science, brought it to IBM Research, spent about 6 years there, expanded from doing only speech to speech and text. That was also the time when IBM acquired IBM Daksh, which was the call center, and so we had a lot of speech analysis to be done, but also a lot of call log analysis, be it emails or chats and so on. So, sort of diversified into NLU, natural language understanding. Then I did a big project around how can analytics be applicable not just in the research setup, but in a business setup. And that was what was then called as GTO, Global Technology Outlook. Where is the next $1 billion for IBM? That is what the business problem was. It was very exciting, was able to present that to the CEO of IBM and all her directs, sort of explaining to them where is the next $1 billion. This was in 2012. Where is the next $1 billion in analytics? And the vertical that we had chosen was education, not just K to 12 or engineering or corporate training, but the entire gamut. And then I moved to Xerox Research. One of the things that we did in Xerox Research was build a lot of multimedia analytics technology. So multimedia is basically when you have speech, audio, video, images, all of different kinds of medium coming together, becoming multiple mediums, so multimedia. And then how do you extract information out of it? We built the solution not just to prototype, but to actually have it in the hands of end users through a startup. So that was a good learning in Xerox, to build solutions, but now also make sure that somebody is using them. And that really encouraged me to then make a switch to the other extreme, which was head a delivery organization. Does everybody know what I mean when I say head a delivery organization? It's the organization which delivers solutions to the end customers. So if something goes down, your neck is on the line. And coming from a research setup where all you had to do was very tough, so I don't want to say all you had to, but one of the things that you had to do was come up with new ideas, show that they are state of the art, they're possible to solve a particular problem, and not really worry about the actual feasibility of it, be it from a business perspective or be it from a monetary perspective. And now to head the data science, data-driven product delivery organization was quite a big switch. So I remember it very well, 2016 August when I joined, I had no idea what QA meant, which of course, it's laughable now, but at that point I had no idea what QA meant, and it's just basically quality assurance, making sure that the quality of the product that is going out is right. The other funny thing that happened was our systems weren't ready, and I knew it'll take another week, and so I just went and told my boss, it'll take another week. Thinking, in a research setup, 1 week is okay. You can always say that I've gotten 95% accuracy, 97 is what I had committed. I know I have a line of sight. Give me 1 week, I'll get you the accuracy. And all hell broke loose. He's like, the customers are waiting, they're paying for this. How can you say you'll take 1 more week? And that's when I realized that if you are the head of delivering, if you're heading an organization which is delivering a solution which people are paying for, not just people, but organizations are paying for, and in this case, it was financial organizations. You better make sure that the timelines that you've committed are very are sort of set in stone. That no matter what happens, you cannot dilly-dally those timelines. So it was a very good learning, and that's why I said live production, at-scale solutions that met stringent SLAs. And then, over the past year or so, I thought maybe now I'm ready to take a big leap of faith and start doing all of this on my own. And so November last year, which is just about 2 months, I started my own startup, which is called TildeHat. People who are familiar with machine learning would know that tilde is what we use. But by the way, can anybody guess? I ran a little bit of a poll on LinkedIn last month when we announced the name, to see if people will be able to guess what tilde and hat would stand for. We got a couple of people who came very close to guessing what it meant. But tilde basically is when we are writing anything in a mathematical way to represent random variables or random processes, we write tilde, right? We say this particular, the inter-time arrival of people coming in, if it's a random variable, then you say, okay, if that is a x tilde, well, in this case, not be n, it won't be Gaussian, it'll be a Poisson process. So tilde is basically a way of representing that what I'm trying to estimate is random by the very nature, and it's not a coincidence. And hat, if x is the random variable that you're trying to estimate, the representation of the estimation is x hat, right? And so that's why TildeHat is the name that we came up with. Okay, so that's the idea. Right now it's just 2 of us. Samiran was part of my team in Yodlee. He did his MTech from IIT Bombay. One of the really cool things that he did, and he's very shy about talking about these things, is he built agents which will supervise themselves when they make mistakes. And that's the crux of reinforcement learning, by the way, right? So his MTech thesis was what are systematic ways in which you can come up with ways in which agents that are trying to learn something. So let's say there is a problem to learn about how do you distinguish between black and white, or boy and girl, or grown up versus child. You give the data, and then somebody else comes and says you made mistakes here. Are there ways in which you can make the system learn it by itself? That's really what reinforcement learning is. And he built that for any generic systems, and then he took it for soccer and so on. So anyway, so good to have him in the team. Okay, so a lot of the times when people say that they're doing machine learning, typically they say, I know CNNs, I know RNNs, or now they say, I know transformers and I know BERT, and I'm sure everybody has heard those keywords. Please show of hand, how many of you have heard about transformers or BERT and so on, right? Okay, so people who have not raised their hands, these are Very good techniques, by the way. Don't get me wrong. These are wonderful techniques. I have had to spend quite a lot of time learning really how is a transformer different from a pure attention model in an RNN setup and so on. But when you are building systems, just knowing that this is a transformer versus this is a RNN setup versus this is a bidirectional LSTM is not good enough. A lot of us really stay focused only on this piece, but the reality is this, that the ML component is just this piece. There is a whole lot of things that have to go around it before you can have a system. I'm talking about system, I'm not talking about a lab project which you've done as part of your course project or any such thing, which you have to build so that the system is usable by somebody for a practical purpose. And when I say a practical purpose, either somebody is paying for it or somebody is deriving value out of it and you will monetize it later. That's really the only way of defining what is valuable. Yeah. And I'm not saying this. Google said this in a paper, in a NIPS paper in 2015. This was a workshop paper. If folks are interested, I would really encourage people to go read this paper. Do people know about technical debt? So technical debt, the idea is when you're writing code, everybody is in a hurry to write the code, obviously, right? Because there's a deadline or you have a movie to go watch or something or the other. So you learn systematic ways of best practices of writing code. And then when you're actually writing code, you sometimes cut corners. I have done it, I still do it. And that's just being pragmatic. But when you do it, you have incurred some debt. And what is that debt? That debt is, let us say, for example, I defined some function in Python and I did not write the comments for it. Like I did not write the doc test. Doc test is basically a way of testing your function, right? So let's say I didn't write a doc test for it because I was in a hurry to test it. I wasn't sure if people will use it. And then I forgot about it because I had some meeting to go and it just went into cold storage. 2 months later, I give it to you, let us say, to use it, right? Now you have to spend some amount of time to really understand what the code does. Because I've not written any comments, I've not done any doc testing or any such thing, right? That is the debt that you've repaid. You see what I'm saying? So that's what is called as technical debt. Now, when it comes to machine learning or building algorithms which are data driven, which may or may not have machine learning to it, it could just be simple pattern recognition in it. The technical debt that gets incurred is very different. So one big difference is when you're writing normal software code, a bulk of the errors are syntactic errors, right? Whereas the bulk of the errors when you're writing a machine learning code are not syntactic, they're logical. And so what that means is your system will compile, your doc test may pass, but the output that you're expecting may not be the output that the system gives. And you will not be able to recognize this till you run the system on many samples, right? And that's where the technical debt that you may incur, that you will incur when writing machine learning codes becomes that much more important. So one example is, how many of you here have used TensorFlow? Okay, so a bunch of you have used it, right? So in TensorFlow, there is a way, or if you've used Keras, there are off-the-shelf ways in which you can use LSTMs, right? There are ways in which you have to change a particular parameter, a particular variable, so that the LSTM is by LSTM. If you assume it is a by LSTM just because somebody gave you the code or you pulled somebody's GitHub repository and that guy said, this variable has to be made 1, the system will work even if the variable is 0, but you will never realize that it is not learning in the reverse order. So that's what I mean by the technical debt that is incurred from in the machine learning perspective is not so much syntactic, but it's logical. Yeah. So that's an aside. I didn't want to go in that topic for so long, but anyways, if you guys are writing code, pulling somebody's repo from GitHub, GitLab, ensure that you really understand what is being happening and so on. And which is not just this component, but a lot of other stuff. What is the configuration that is being used? What are the kind of features that are being extracted? What kind of logic went into collecting the data and so on. So what I will do in the next 15-20 minutes is just zip through a lot of what I have learned in terms of how these things have to be done. Yeah. Stop me if this is too fast. Definitely tell me if this is irrelevant, and then I can go on to the next topic. Yeah. Any questions, comments? No? Okay. So I get asked this question very often. Why is data science so relevant today? Is it really a hype or is it really valuable? And my answer genuinely is that it is not a hype. It is truly relevant. It is truly relevant. And I have this slide, I've borrowed this from somewhere, which will hopefully make this point. Every one of us came here using some automobile or some mode of transportation, I'm guessing, right? Unless folks stay in hostel, but ignoring that, or people who went out on over the weekend or over the vacation, must have used some automobile to go, right? The place that you went, let's say, had no internet connectivity. So you probably, let's say, did not use Facebook or WhatsApp or Instagram for a week. Now, if you had to choose between a place that had connectivity, physical connectivity through automobiles, versus a place that had internet connectivity, if you are like me, you would choose at least the first one. That come se come, at least it should have physical connectivity, right? If it has digital connectivity, it's fine, it's a bonus. Agreed? Everybody agrees? Right? So between the two, physical connectivity is a necessity. The other one is probably not as much. So now guess how many years it took automobiles to go from 0 to 50 million users. The answer is here, but hopefully the slide is masked so that you don't get the answer obviously. It took on the order of 60 years. Essential thing like going from one place to the other, for it to go viral, which in this case I'm defining as going from 0 to 50 million, took about 60 years, 68 years, I think that's the actual answer. Now WhatsApp or WeChat, which we all agreed 5 minutes ago or 3 minutes ago is not as essential, how long do you think it took to go from 0 to 50 million? 60 years was the other benchmark. It took 13 months, took just about a year, yeah? And that to me is a true example of why data science is very relevant today, yeah? Clear? And I'll explain why that is the case. There are 3 pillars, and in interest of time, I'll just lay out the whole thing. One is there is exponential growth in the amount of data that is getting created. New data gets created. It's not the old data that is, not only the old data that is getting digitized, somebody scanning or taking photos or some such. New data is getting generated, be it Twitter, be it WhatsApp, be it Facebook, Instagram, whatever else. New data is getting generated, and that's happening at a very rapid pace, right? A. B, thanks to geo and the competition that it has spurred because of it, creating the data was okay, but now you're able to also transmit that data very easily, and that has an exponential viral effect. I get somebody's message, I am sort of under peer pressure to like it or dislike it or comment on it. So there is creation of data because of all the smartphones and all of that. There is also transmission of data that is happening, and it's just going to keep growing. So that's one source, one reason why data science is becoming relevant. A, you have a lot of data, which wasn't the case a few years ago. B, yeah, so actually if I had a little longer time, I would have gone through, made this into a quiz. The second is, once you have the data, you have to have ways in which you will process it, right? Just about few years ago, Tensorflow came when, 2016, I think, 2015, the first version. Before that, I mean, there were a couple of other things, PyTorch and so on, but let's go back 10 years ago or 15 years ago. When I joined IBM Research, the speech recognition system that we were using in IBM was not open source. In fact, there was a very small section of IBM people, IBM Research people, who knew how to use that system. I had to go through a month's rigorous training just to understand how to use the system. Would you spend that much time today to understand how TensorFlow works? Only some of you will. But you don't have to. That's the beauty of having GitHub, GitLab, and all of these repositories which are open source. You just read a Medium article or you read some LinkedIn article and you are good to go. You can start using the latest transformer or the latest sec-to-sec model or any such thing, right? And that's the second thing that is happening, is a lot of models are available. So that's what I call as the democratization of the deep research that went into building all of these models. It's sort of hidden. You don't have to know the details of it to really start using it. So that's the second reason. What can be the third piece of the puzzle? So you have the data, you have models to process it. What do you need now? Compute power. And has that changed in the last 10 years? Yes, right? How? I see a lot of heads nodding, so that's good. Can one of you? Parallel computing, but that was happening even earlier. Speed has been increasing. Moore's law has been there for forever now. Yeah, but but all of that it's been there. But what has changed fundamentally in the last, let's say, 10 odd years or less than 10 years? Cloud. Somebody said cloud, right? See, 6 years ago or 7 years ago, when I was starting the multimedia analytics group in Xerox, I remember we had to spend a lot of upfront capital to buy GPU machines. Then we had to hire a system administrator who knew how to set up the whole NVIDIA setup. I still don't know. We had to hire somebody who could set it up for us, which means A, cost, monetary cost. B, we had to have the infrastructure, the cooling systems and all of that. What do you do today? I just go to AWS or Google Cloud or whatever else, right? Or Azure or whatever. So that's the third thing. And that's why a lot of startups have now started. Because the entry barrier, which was a huge amount of capex, capital expense, has gone off. All you have to do, in fact, all of these major players give you free units that you can just go use. So that's the third thing that has happened. There is easy and cheap access to humongous amounts of compute power. Clear? Because all three of these things have come together, the first LSTM algorithm, can anybody guess when the first LSTM algorithm was published from a research perspective? Yeah. Oh, 97? No. 81 or 82. It was that old. But anyway, even 97 is a good answer. It happened that many years ago, but we started using it only now, largely because of all three of these things have happened. That you are able to access a large amount of data because all of these deep learning based systems are data hungry. Second, you are able to, LSTM or RNNs or any other techniques are now relatively easy to use even if they are a black box. And third, you have ways in which you can use it, right? Why am I telling you all this? Because if you are now trying to do something practical from a machine learning perspective, it's not enough to know how transformers work or to have a Git repo that you've pulled about transformers. You also have to worry about these things. Are you able to get access to these things or not? There are new classes of problems that are coming up. I'll lay them down and then I'll sort of tell you what has to be really thought through. Just about everybody wants to do this, right? Everybody wants to take the data and come up with some cool value out of it, which is valuable. Yes, absolutely. But that's just the tip of the iceberg, or that's just the icing on the cake, or use whatever analogy you want. A lot of the things have to happen before you get there. Yeah? And the way I have arranged it, it sort of goes in that order that you start. So if you think of this as an inverted pyramid, this is the tip. These are the fundamentals that have to be done before you can go to the next level. The first one is data capture. While there are mobile phones and sensors and IoT is becoming a big thing, you really, before you can even think of what value to derive, you really have to worry about what is the kind of data that I want to capture, what is the kind of granularity that I want the data to have. But once you start capturing data, you also have to worry about the cost of that data. And when I say cost, it's not just the storage cost, but also the responsibility. So imagine you are a big company, you have a lot of money to store the data, right? S3, AWS S3 is relatively cheap. So let's say you stored the data. So that's not the cost though. The cost is if you are storing the data and you have the ownership of the data or the custody of the data, any leakage that happens of that data is a huge bad press that you are inviting. That's the other cost that companies should worry about, small or big. Anybody should worry about what is that cost, and hence really think about whether the data that you are using, that you are capturing, is needed or not. Third is data retrieval. Again, I won't go through examples, but you have to worry about whether the contextual data is important, having all of the contextual data is important, or getting the data in real time is important or not. Right? One example of having contextual data is when you have financial data. You need high fidelity. Even if somebody says, I will reflect this data in your account after 2 days once I have verified the KYC and all of that, because there's humongous amount of money involved, you will give the person or give that entity that kind of a leeway. On the other hand, if you are booking a Tatkal ticket and it's only a small amount of money, but there's a big thing at stake because your vacation is at stake, you want real time. So you have to really worry about the kind of value that the end user is going to get, and then build your databases so that the retrieval is either real time or high fidelity or something in between. And again, there is a humongous amount of research that is going into in this field. Have folks heard about Kafka and so on? Yeah. Okay. So there's huge amount of research going in that direction also. Then comes the data processing part, which is not the data modeling. It is just data cleaning. Most of the time, well, not most, all the time, the data that you get is not the data that is ready for modeling. You have to do a lot of what is called data massaging or data curation or data cleaning and so on. I like to call it as data swimming. It's only when you swim through the data that you will be able to understand what, which regions have strong currents, which way the water is flowing, and then so on. And a lot of people who join my team, or used to join earlier, now I just have one person, do not appreciate all of this. So I spend a lot of time just talking about these so-called uncool things. But if you spend a lot of time learning about these things, only then will you be able to derive the actual insights which are actionable. Yeah. Okay. Any questions, comments? No. Okay. Yes, and the fundamental shift is everything is going from being generic to specific. Everybody gets very specialized alerts, and everybody gets very specialized things to shop for or friends to connect and so on. That's the fundamental shift that is happening. Anyways, I won't go through it. But now let's come to what are the practical things that we need to worry about. First thing that we need to worry about is data science applicable everywhere? The big management or your resume or the job that you're seeking for may be all hungry to have the word data science in it. But I'll tell you, a lot of problems don't need data science. A lot of them just need deterministic, rule-based automation. So let's look at places where data science is applicable. So the first three are technical reasons, and the other two are business reasons. Given the audience that we have, I won't go through the bottom two. But the top three are, whatever problem you're trying to solve, if that problem has consistent patterns which are explainable by a human, then that problem is ready to be solved by a data science approach. Clear? It has to have some consistent pattern, which means it's not a random variable, which means it's not a dice which you roll and whatever value comes up is the final outcome. There has to be some pattern. It may be very difficult pattern. It may be a pattern that is not seen or not recognizable by a naked eye, but a human expert knows that there is some logic in that madness. As long as that is there, that's one requirement. Second requirement is the data on which you are making decisions has to be more dynamic than the amount of time it takes to make a decision, right? So for example, in this audience, I think what will be relevant for this audience is if the decisions of whether a student is passed or failed gets made only and only at the end of a semester, that's every 5 months, let's say, because there's 2 months of vacation, then the data that you are getting is every 5 months, right? I mean, the decision that is happening is every 5 months. You may not need a lot of machine learning there. If the decision is continued to be made only after 5 months, You can make it granular and so on, but you don't need to really worry about whether that brings value and what kind of dynamic or paradigm shifts it needs and so on. And third is the data has to be voluminous and diverse. Why do I say it has to be diverse? Let us say the problem is about recognizing whether the given image is of a boy or a girl. Clear? Everybody is clear on this problem. Now, you don't need machine learning if I tell you upfront that I only have 10 boys and 10 girls, and till the end of civilization, my problem is only and only to solve this 10 boys versus 10 girls problem. The data is not diverse, the data is not voluminous, the data is not dynamic. All I have to do is come up with rules and stick it. That's it. Right? So this is the third thing that you need to worry about. Is your data voluminous, diverse, and is it changing dynamically? A lot of the practical problems that you will see will have all of this, but to get there, you need to solve these two problems, which is the data has to be available. It should not be in silos and so on. Okay. Now, assuming the data is there, how do you teach intelligence to the machines? Okay, I'm going to skip through a lot of this. I'll come to what are the textbooks that you should use. A lot of the times when we use Kaggle competitions, has anybody used Kaggle competition here? Yeah. I'm a big fan of using Kaggle competition to sort of cut your teeth in terms of understanding what does it mean to do competitive coding, or what does it mean to do to use data science algorithms, right? One of the things that Kaggle does for you is it gives you the data and it also gives you the labels on the data. Now imagine you started your own startup, or you joined a company where the data science efforts are just about beginning, which is, by the way, 99% of the companies, where they're just truly beginning to use data science only now. Because of that, what happens is they won't have the data labeled, right? And so all the algorithms that you've used will come as step 5 or step 6. Step 1 is to get the data labeled. If you're using a supervised technique, eventually everybody will need some amount of supervision. But let's skip through all of the unsupervised, semi-supervised methods and come to the final supervision. This is a simple example. Let's say the machine has to distinguish between red and green. What do you have to do? The first thing is you have to have 100,000 images which are red in color and have the label red. Some human has given that label. Similarly, you need 100,000 images which have the label green, which are actually green, and a human has given the label green. Clear? Everybody agrees with this? It seems like a relatively simple thing to do. You can get maybe 5 people, 10 people, or you can crowdsource it and you can get all of these. Clear? But this is not, how many of you think this is a real world problem? I hope nobody, right? Nobody should think that this is a real world problem. The real world problem is actually this, is you have the entire rainbow of colors, and now the problem is not so much to distinguish between red and green, but it is to distinguish between navy blue, dark blue, and violet. And now what is the problem here? The problem is when you are creating the data labels, you want the human experts to be quote unquote trained in a particular way so that everybody who's tagging the data agrees that this is light blue, this is dark blue, this is violet, and this is I don't know. I don't know is a wonderful label to have, by the way. At least what is happening is you are not confusing the system, right? Imagine if you did not do that, right? You just said, do something, give me the labels. Your system is trained with garbage, and hence the output you will get will also be garbage. And hence the saying garbage in, garbage out. I mean, ultimately there has to be some supervision. If that supervision isn't high fidelity, your systems aren't going to be trained well. Yeah? Yeah. Sure. Yeah. Yes. Yes. Yes.
We spend a lot of time on design of survey methods, design of samples.
Right.
So that it is
Right.
we don't have to really worry about the data once it is acquired because it's already met some conditions, including normality, unbiasedness, and so on.
Yes.
So here, when the data is available at ease, we don't spend a lot of time in doing this method of data collection. Data collection comes easily, but we spend a lot of time in labeling so that the supervision is, testing the appropriate hypothesis, properly and so on. So we have just now shifted the amount of time that we spend in collecting data to processing and labeling data. So are we gaining anything at all?
Yes, but very, very valid point. And the answer is a firm yes, by the way. And I'm obviously biased because I am from data science background, but hopefully I'll try to convince you. If not, we can have a conversation outside of this talk also. So the initial systems were essentially purely supervised learning. Now there is semi-supervised learning, and in fact it has now gone to the extent that you can have non-parametric learning. So what I mean by that, and then we'll come to reinforcement learning, which is like a completely paradigm shift in terms of how learning happens. Everybody knows clustering, right? The fundamental thing that we have to do in clustering is what? What is that? Huh? No, not even at that level. I am doing k-means clustering. What is the first thing that I have to do? Define k, right? That's the first thing we have to do. Typically, in a toy example, the k is given to you, but in the real world is not toy. So the first thing you have to do is define k. That's where, sir, what you said becomes very relevant. Is some human expert who has spent a lot of time looking through the data says the k, in my opinion, should be 3, or it should be around 3 and not 30. And then the team will go and say, okay, let me try with 3, try with 4, try with 5, draw the curve and see which one gives me the lowest error, and then that's the k that I have finalized, right? Now that's one extreme. And then you can always talk about hierarchical clustering and so on. Everybody knows about hierarchical clustering. That sort of goes away from having the problem of having to define what the k is. It says, I will sort of do either cumulative, agglomerative, divisive, or agglomerative, cumulative clustering, right? But what BNP does, and I've worked in this field for quite some time. When I was in Xerox Research, we had some publications and patents in this. What is called as BNP, Bayesian non-parametrics. What it says is I will define k to be a random variable, and that random variable's value is dependent. I'm overly simplifying it, so don't quote me on this, although it's being recorded. But so okay, that value will change as the data changes, right? So people who are familiar with non-parametric ways of learning Bayesian techniques will know that that's a big shift that has happened. And so the kind of very restrictive human data that you needed, very specific human data that you needed is now not that specific. It is now getting relaxed. Reinforcement learning is now taking it further, where you and I as kids, we learned cycling not by looking at a supervised technique that says, this is how you ride a cycle so that you don't meet an accident. This is how you ride the cycle so that you don't fall down. We didn't learn it like that, right? We learned it by falling a few times, or our elder brothers or elder sisters or parents helping us with learning to ride the bicycle, which is basically some self-correction kind of thing that is happening. So reinforcement learning is bringing that amount of, is doing exactly that, by the way. So to answer your question, yes, we still need a lot of supervision. The data that was painstakingly labeled over the past decades is of extreme value. In fact, in Yodlee, I had a team. I had to build a team. I had to convince my management, not that they were opposed to it, but I had to convince them and build a team which was of experts who provided that labels for us. But what we were able to show was the growth of that human effort can be sublinear in terms of the growth that you want from the accuracy perspective. That's the difference that is happening today. is 20 years ago, the amount of human effort that you needed to learn will grow linearly, would have grown linearly. Now it doesn't have to grow linearly. Does that answer your question? Any questions? Yeah.
May I add something?
Sure, please. Yeah.
Yeah, so I think the one big thing that has happened is maybe earlier when you were doing a lot of manual sampling and sort of thing. But I guess a lot of time was spent in sanitizing the data in terms of features, normalizing them and all that. But that still doesn't take the problem of labeling the data points away. You still have to label the data points for your model to learn something from it, right? Now, what is happening now is that you're actually spending less and less time in sanitizing the data. In fact, to some extent, you would welcome noise in the data so that your model is actually robust when it is thrown into the open world outside, right? So you're actually spending much less time sanitizing the data. The only effort now is in the labeling, which was there earlier, it is there now as well, right? But the effort of sanitizing the data is actually going away because your models are expected to be robust enough to learn from the noise that is thrown into the data, so it can actually work in the wild world outside.
Yeah, very valid point. Yes, in fact, the autoencoders, people familiar with autoencoders. I'm just adding one very specific example to what you said. Very true. Autoencoders, the way they were initially learned, were with full sanctity data. Now, by design, you do noisy encoders, noisy autoencoders, where you either drop some connections or you remove some of the data or using some elements of the data, so that the system is by design robust. Absolutely, yes. I mean, there are techniques that are coming up, and hence that effort is going.
Given the sort of volumes of data that you have with you, it looks like a lot of the very careful sampling techniques that you used earlier to ensure that your data is IID and all that is actually getting irrelevant now. Because you have some random approach. I have to reinvent a course. Seriously, right? See, if you have to depend on maybe a handful of data points or a few hundred, then the sampling actually becomes very important. But if you have a million data points, it is it is going to be representative of the population, right? Very, very likely. So if you really don't worry about too many of these sampling techniques and all that, so finally all you have to do is throw a network at it and
No, that is too extreme. No, wait, let me. So, yeah, I don't have those slides here. Yeah, okay. But sampling, that was the other point that you had raised. I have a slightly different view of the sampling piece. Sampling is absolutely important. And coming up with data-driven ways of sampling. I mean, not that you said it's not important. You didn't say that, but I'm saying that sampling. There's a lot of data-driven ways in which you should be doing sampling. In Yodlee, one of the big things that I did was not just building the data, the deep learning models and all of that. Was come up with a very novel technique which Yodlee has patented of sampling the data. See, what happens in that setup is financial transactions. Most transactions are digital transactions these days, right? I mean, we pay through some wallet, or we use our credit card or some such. And so the amount of data digital transaction data that comes up is millions of transactions on a daily basis. Millions of transactions, right? Now, I had to get some of it labeled, right? And that everybody agrees that some data has to be labeled. But now, which data has to be labeled is a problem. And that is where we had to come up with sampling techniques. So it's not one technique, it's a combination of several techniques, but the one final technique that we came up with, the samples that so let's say we got 1,000 samples, that would actually be representative of close to 1 million samples. So we had to come up with A, data-driven techniques, B, a lot of human expertise, so that the labels that we were asking of the humans were diverse. Can I draw something here? Because this is a topic that is very close to my heart, and if people are talking about sampling, I just want to make this point. Here, can I just draw here? Yeah. Yeah. Okay. So let us say your data is only two-dimensional. Yeah, this is your x-axis and y-axis. Very simple toy example. Think of anything that is just two-dimensional, height and weight. And let's say you know that the data lies between 0 and x or x1 and 0 and y1. That's all you know. Now, sampling here is very easy. How? I randomly close my eyes, sample one point. Once I see where the sample is, to get diverse samples, all I have to do is go to the other extreme, right? But I mean, go to the other extreme, and then that's how we do k-means initialization and all of that. But now imagine if this was 1,000 dimensions, right? And you randomly picked one sample, you gave it to the human for labeling, or you gave it to the machine to learn by itself. Where you pick the second sample, so that the samples around this region are not picked, is a very difficult problem. Because how do you define? In this case, I sort of led you all to think of Euclidean distance as the distance, but I can always change it, saying it's not, the Euclidean distance is not the right distance, and so on. At higher dimensions, when you're thinking about hundreds of thousands of dimensions, that becomes a very complex problem. And that's a big problem with text data, that the dimensions that you want are not very clearly defined. And so we have to spend a lot of time doing sampling. So sampling is I think still a very, very tough problem to be solved if you have resource constraints. Okay. Okay. This is good, by the way. This is good. I'm glad there is a lot of back and forth and conversation. Any questions, comments? Any more comments that is on this, or any other thing that I covered so far? No? Okay. So here. Yeah. Okay. So I was talking about subjectivity in the data and how you have to have some amount of benchmarking in your data. And again, through a lot of these noisy techniques, robustness in the systems, the reliance on having high fidelity data is definitely going down. Okay, the other thing that you need to worry about is how do you penalize? Right? I mean, so the way I'm building the story is, think of machine learning as teaching a kid, some exam or some such. So you've decided the course or the curriculum, you decided the textbooks, which is the human labels, and now you have to evaluate the system, right? Because only after you evaluate and you give feedback will the system learn, right? So now let us say your problem was to distinguish among these three images, yeah? Cat, dog, and a jaguar. Yeah, those are the three images. Don't really spend too much time trying to come up with what are the ways in which you should really be quantifying these differences. So what I've drawn here is the jaguar is equidistant from a cat, which is equidistant from a dog, which is equidistant from a jaguar, which seems like a reasonable thing to do in a toy example. Now, if the final problem was to distinguish between domestic animals and wild animals, you would much rather that I confuse these two a little more than I confuse these two, right? Because one can eat you, the other one won't. So there's big life at stake, which is, by the way, the case with most of the places where these things get deployed. Yeah? Be it self-driving cars or healthcare or financial transactions or whatever else. So become big thing. What if the problem was not wild versus domestic, but cat family versus non-cat family? In both these cases, which are actually more practical than having distinguishing all three of them equally, this distance metric is not right. Does everybody agree? And hence, you have to have, if the problem is domestic animals versus wild animals, because there's life at stake, or rather human life at stake, you will want to have a cost function which is reflecting the actual value that you're trying to derive. So again, very little effort goes into coming up with the right kind of cost functions. I insist every person who joins my team to really spend time to understanding what cost function a particular deep learning algorithm is using, or any SVM that you're trying to do, or even just any pattern recognition, any clustering that you're doing. Because if you're doing Euclidean distance, you're going to have a very different kind of clusters because you're penalizing something else, something different compared to, let's say, you had angular distance or cosine similarity or some such. Yeah. By the way, that's one of the big reasons why Gyan, everybody knows Gyan, at least heard of it, Gyan, right? Why they are so popular, because they have fundamentally changed the cost function, and then of course there's now a lot more addition to it. Yeah. Okay. So that's the other thing that needs to be worried about. Okay, so now this is the kind of work that I had done earlier. The transactions were financial, but I'm going to not talk about any financial data. I'm going to talk about how NLP comes into it. What is the kind of text processing or natural language processing that has to be done. So I say the problem is identify the person mentioned in these lines. So the first one is I met Jaya in the corridor. Oh, sorry, I met Dr. Srinath today. I haven't met him yet, but okay. I met Jaya in the corridor. I met the athletic Rahul. I met Mr. 7 Racecourse Road. Now you have to guess the names, and in some sense the complexity goes up as you go down. Yeah. So let's start with the last one. What is the answer? Huh? 7 Racecourse Road. No. Modi. Who said Modi? Modi. Yes, it's Modi. And I met the athletic Rahul. Huh? Dravid? Yeah. Yeah. Why not Gandhi? We'll come to that also, because you said it's Rahul Gandhi, right? So in this case, it's Rahul Dravid and not Gandhi. We'll come to that that's a strong statement. What I would say is you would associate Rahul Dravid with more you would associate Rahul Dravid a lot more with the adjective athletic than a slight difference, but you know. I met Jaya in the corridor. I'm not giving you the last name, nothing, but because it's in the corridor and I'm talking about today, you know, you have no problem guessing who it's a professor and so on, right? And I met Dr. Srinath today. I've given you everything there, so you know. Now let's start with the last one because we don't have a whole lot of time. But this is, so what has happened, when you said it is Modi, essentially what has happened is, I mean, if we had time, we would have done this as a back and forth, you know, what happened. But essentially what happened is you had 3 or 4 ginormous lookups in your mind, which you hopped very quickly. So the first lookup was, and tell me if it's wrong, 7 Racecourse Road is not a name of a person. You had a lookup table in your mind which was a list of names or things that sound like names, and this wasn't there. So you immediately move to some other lookup table, which was, oh, if it's not a name, then what can it be? And so you went to your address lookup table, and you're like, oh, this is an address. So that's the second lookup table. Then you're like, okay, the third lookup table is what are the famous addresses, right? And that was the Prime Minister's address. So you got that. Then the fourth lookup table was who is today's Prime Minister. Right? All of this you did in nanoseconds, or less than that actually. You knew the answer, right? Making a system do this is extremely difficult. Now, one simple answer is, oh, you know, it's very easy. I'll have 100 lookup tables, and I'll fill them up with 100 values, and that's a problem. Easy, done, solved. But now go back to the first slide, one of the first slides I showed, where I said there was 2 terabytes of data in all of Twitter in 2012 or some such, or 2 terabytes of data in all of US Congress, Library of Congress, whereas Twitter generated 16 terabytes of data in a day, right? This was in 2012 when there was no images or videos in the Twitter feed. This lookup logic fails there. Because now you cannot have that kind of ginormous lookups. You need to have ways in which the inference happens, which is the way your inference happened in your mind, that you had the lookups, but you had the inference to figure out which lookup table to see, and then how do you do the matching and all of that. That's a very complex problem to be solved, extremely complex problem. And what makes it even more, I'll tell you also what makes it even more complex, but that is the kind of problems that we have to solve in the real world today. And this is not even at the scale of what Facebook, Google, Instagram, or any of the WhatsApp, or any of the big guys, Amazon, how can we forget Amazon? They have to do, because for them, the amount of data that they have to sift through is just ginormous. Yeah, so that's where truly data science becomes very important, and we were able to do quite a lot of it. I'll just talk about, if we were using some of the old techniques, if the problem was of recognizing names, the persons that I showed, old technique, and this happened by the way with us, was able to do only 1200, because then the lookup table was memory full, and the accuracy was 74%, and it was taking X amount of units. When we brought in some very fundamentally different deep data science ways, when I say deep, not just deep learning, but really very systematic ways of doing data science, this was our output. The number of faces that we could recognize went from 1200 to 3 million. The accuracy went up from 74 to 96. So mind you that the accuracy is not now on 1200. The denominator has also gone up, right? And hence the numerator has gone up by a lot more, 74 to 96 and 1200 to 3 million. And because we were not doing just lookup tables, because we were doing some, we had learned a few things, the compute cost went down to 1/12. That's the power that deep systematic way of doing data science can bring in a practical setup. I'm a data science guy. I've spent most of my adult life doing this, so I'll firmly stand by data science. And yet I will say this, that data science is not an end by itself, it's an end to a means, right? And that means most of the times is the user interface, right? And so what is the kind of user experience you're providing, what is the kind of interface you're using, and so on. And I wanted to give you an example of how Google does this. This is Google search for Prime Minister of India, very confident, so it did not give you, so the UX changed. It wasn't very confident here when I asked where do MPs meet, because the first answer was right, but wasn't confident, so dynamically, not dynamically, but it changed the interface which the human was looking at. Another better example is this. You type TEH in any word processor, it'll automatically correct. So, and again, there's a machine learning algorithm behind it. Second, it gives you options. Third, it doesn't give you any options. So the same problem, same machine learning algorithm at the back end, but the UX gives you that aha feeling. Now imagine if it had changed this completely to this, you'll not be very happy. Initial days of word processing, we used to have this problem. We used to say, "Ki yaar, ye kuch zyada dimag laga raha hai." I don't know if you people, some of the people who yeah, you can relate to this, right? Phone does that very often. So it has to get to that machine learning is not an end by itself, it's a means, and the UI UX has to really enhance the good things about your machine learning algorithm and try and camouflage the places where it is making mistakes. We have had to do quite a bit of that. Okay, so anyways, okay, what are we doing at TildeHat? We are trying to look at HR analytics at this point, and so this is the profile. Not profile, this is the job description that is on LinkedIn for either my role or a role that would be in my team in Yodlee after I left, right? So that's the one side of the data. The second side is, this is my LinkedIn profile. And so the idea is, what are the ways in which you can match these two? I just wanted to sort of say that this is a big problem to be solved today. A lot of text data, what are the ways in which I can do some matching? We are beginning to think about some ways in which all of this text data on the left side can be matched with the nuggets of information that you can extract out of the text on the right side. Again, a huge problem to be solved. It so happens that we are thinking of doing this for HR in the HR analytics space, but this can be applied in a variety of different problems. Okay, so I think that's all I had. Thank you.